We're going to do section 7.5, using proportional relationships today. So using proportions kind of in some real life examples to help us solve. Okay, so using proportional relationships, section 7.5. First thing we're going to talk about here is a scale drawing. A scale drawing is a drawing of an object that is smaller or larger than the object's actual size. The drawing scale is the ratio of any length in the drawing to the actual length of the object. So for example, the scale for the diagram of the doghouse is 1 inch to 3 feet. So 1 inch is equivalent to 3 feet. And it says, find the length of the actual doghouse. Well, it gives me one ratio here, 1 to 3. Alright, now they convert feet to inches. For example, how many inches are in a foot? 12, so I took 3 times 12, and we got 1 to 36. Now I set that up as a proportion. Diagram length, actual length. So 1 over 36 equals 0.75 over x. When I work that out, you get 27 inches. And then you can convert that back to feet and inches, which is 2 feet, 3 inches. Because basically 27 divided by 12 is 2, 3 left over, so you had 3 inches. 2 feet, 3 inches where you got there. Okay. So we're going to be using some conversions and some scale drawings and proportions. Alright, so the first one here says the scale of the cabin shown in the blueprint is 1 centimeter to 2 meters. Find the actual lengths of the following walls. So what's my ratio I have here?
1 to 2.
1 to 2. So I have 1 to 2 here. Find the actual lengths of the following walls. Well, the first one says HG. What's the length of HG?
5
Is that going to go in my numerator or denominator? Numerator. So 2.5 over x. So 1 over 2 equals 2.5 over x. When I work that out, what are you going to get for an answer now? 5 meters.
If you're kind of doing that, do you have to do proportions like that?
Yes, sir.
So it's a scale over...
Scale over actual. Yep. Drawing or scale over actual is always what I do. Yep. 2. GL. I want to find GL now. Well, GL is its bottom length. Set up a proportion for me here, Chris.
1/2 equals 3 over x.
1 over 2 equals 3 over x. And when you work that out, you get what, Chris?
6 meters.
6 meters. And HJ. What about HJ here? Set up a proportion for HJ. Spence, what are you thinking? Equals? What's the length of HJ going to be?
You said Douglas?
Okay, so number 3 here. 1 over 2 equals... Well, what's the length of HJ going to be, Spence? What'd you say?
4.
2. So 2 over x, then you work it out. What's HJ's actual length going to be, Spence? 4 meters. Nice job. And 4, I need to find the length of JM. Well, JM's right here. Set my proportion up there, Blake. And when you do that, what do you get? 1 meter. Nice job. Alright. Same idea. Take a couple seconds. Try these 4 on your own. Alright, let's look through number 5 here. So a rectangular fitness room in a recreation center is 45 feet long and 28 feet wide. Find the length and width for a scale drawing of the room using the following scales. Well, if 1 inch is equivalent to 1 feet and I were to make a scale of this, what would my new dimensions be in inches? Chris?
The length would be 45 inches, and then the width would be 28 inches.
Yeah. If it's 1 to 1, well, it's just going to be 45 to 28. It's going to be inches now. Okay? Okay, number 6 now. I have 1 inch is 2 feet. Well, if I have a diagram here, and 1 inch represents 2 feet, what are my new dimensions going to be now?
56?
No.
I'll do a general 5 in my head.
22.5 and what? 14. Nice job. 22.5 inches and 14 inches. Again, you have to step twice. You'd say 1 over 2. equals x over 45. And then you'd set up 1 over 2 equals x over 28.
Wait, so the x is on the onwards or what?
No, it kind of depends. They give me feet. It tells me the feet and the feet.
Yeah.
So those both have to be in the denominator. They have to be associated up. You have to match up. 7. 1 inch to 3 feet. Well, if I had a diagram here, what would my new length be now? 15 inches.
9.3 repeating.
And then the other one would be 9 1/3 inches. Nice job. So there's my scales. Then last one, number 8. A little tougher here. I would convert 6 feet 8 inches just to inches.
So that's what, yeah,
How many inches is this?
80 inches.
So really it's like saying 1 inch to 80 inches. And then I'd convert 45 and 28 both to inches. So I'd have 1 over 80
Equals x over 540.
equals x over 540. When you do that, you get 6.75. Okay, then I'd also do 1 over 80 equals x over what's 28 times 12. What's 28 times 12? Is that 336, something like that?
Oops.
And then you get 2 point, what'd you say? 4.2, thank you. Yeah, so then you get 4.2. All right, so those are your dimensions there. All right, so again, just kind of understand the scale. Make sure you set proportions up consistently, so understand if you have a scale, if you have the actual drawings. Okay, it depends if it goes numerator, denominator, etc. Last thing we'll talk about today is we can do this with perimeter and area as well. So we're looking at proportional shapes now. If two figures are similar and their ratio is A to B, then the ratio of their perimeter is A to B. Who remembers what perimeter is? No, perimeter.
Oh, perimeter, all sides.
All the sides added up. Okay, so if the ratio is A to B, then the perimeter is the same ratio A to B because everything added up is going to be the same ratio. The difference here is the area. If the ratio is A to B, the area ratio is A to B squared. Now, why are we squaring it? Who takes a guess? Because when we talk about area, units squared. So what are you going to do? You're going to square the ratio. So what happens here is I find the ratio. Well, let's look at the ratio of the sides. What's 12 over 4? What's the ratio of 12 over 4?
4 over 3.
12 to 4?
3 over 4.
Isn't that just 3 to 1 or 3 over 1?
Yeah.
Okay. Well, if you add up all the area of the sides to find the perimeter, you get 36 over 12, which is 3 over 1 as well. What happens here is when you find the area, so we find the area of a triangle, half base times height, you actually get 54 over 6 or 9 over 1, which is equivalent to 3 over 1 squared. Okay, so you need to square the ratio in order to solve this. Now, why does that help? Because we can find the area of shapes that are similar or proportional. Just waiting for it to change here. Show you what I'm talking about. There we go. So on a problem like this, okay, I have two triangles and it gives me the, says triangle HJK is similar to triangle LMN. The perimeter of HJK is 30 inches and the area of HJK is 36 square inches. Find the perimeter and area of LMN. Well, first off, I want to find the ratio of the sides. I have 9 and 12. My ratio is 3/4. Okay? So I'm going to set a proportion up. First, I'm going to use the perimeter. The perimeter is 30. So 30 over P equals 3 over 4. Cross products and solve, I get the perimeter is going to be 40. Okay? Then this one also gives me the area. It says the area is 36. Well, instead of using 3/4, now I'm going to use 3/4 squared. So I have 36 over A equals 9 over 16. I use cross products. My area now is 64. So what you have to be able to recognize is that you need to square the ratios when trying to find the area. So let's look at number 9 here. It says rectangle PQRS is similar to rectangle TUVW. Find the perimeter and area of rectangle TUVW. First off, I want to find the ratio. What's the ratio of the left rectangle to the right rectangle?
Yeah,
3 over 2.
3 to 2. Because I'm going left to right. If I want to go right to left, I'd work, but I'm going left to right. Okay, so the ratio is 3 to 2. So I want to find the perimeter. So I'm going to say the ratio, 3 over 2, equals, what's the perimeter of the left one? 72 over x. So 3 over 2 equals 72 over x. When I do that, my perimeter of the right triangle or the right rectangle is going to be now 48 centimeters. Nice job. And now I want to do the area. So now instead of using 3 over 2, I'm going to use 3 over 2 squared. What's 3 over 2 squared? So I'm going to say 9/4 equals 315 over x. So 9/4 equals 315 over x. Now I use cross products and solve, and I get the area comes out to be,
440.
was it?
440.
140 centimeters squared. All right. Let's try number 10. I want to find the ratio of the sides. So what's the ratio from the left triangle to the right triangle? 1 to 3. So I'm going to do the perimeter first. So I'm going to say 1 over 3 equals 27 over x. When I do that, what's my perimeter come out to be? 81 meters. Nice job. And then I'm going to do the area. So instead of doing 1 over 3, I'm going to do 1 over 3 squared. So I'm going to get 1/9 equals, what's my area here?
32 squared.
32 over, I don't need to square 32.
Or,
32 over x.
288.
And now I use cross products and solve, and I get, what's this come out to be?
288 meters squared.
288 meters squared. Again, so the big thing you need to recognize here today is the area, you need to square the ratio to set up proportions and solve. All right, take a couple seconds, try these two on your own. Okay, first off, I want to find the ratio of number 11.
2 to 3.
What's the ratio of the two sides there, Katie?
She's not paying attention.
What's the ratio of the two rectangles?
2 to 3.
2 to 3. So set up a proportion for number 11, Katie.
2 over 3 equals 28 over x.
2 over 3 equals 20 over x. Nice job. When you do that, you get the perimeter to be what?
42 millimeters.
What'd you say?
42.
42 millimeters. Nice job. How would I walk through number 12 then, Katie?
2 over 3, you square it. You get 4 over 9 equals 40 over x.
So you get 4 over 9 equals 40 over x. And when we do that, what do you get for the area?
90.
90 millimeters squared. Nice job. Here's your assignment.